Hello and welcome to the AS Water Shader setup tutorial. This is going to be a two-part video. In part 1 we will simply overview the creation of the material, assign a shader to it and overgo the several different settings in the shader itself. Part 2 is going to be about creating, editing and setting up the flow map, which is one of the most important parts of this shader. We will use the provided flow map generator for this task. Alright, let me hide this plane real quick and create a new one. There is a plane provided within the example folder. If you go to example AS Water, models and materials, you will find an example water plane. Now, the first thing that we're going to do, there is a ready to go material also provided. But we're going to make one from scratch. Create, material. Go to the shader section, go to AS Water and select volume water. Now the shader itself has a lot of settings, so let's first apply the material to the surface. And as you can see, the default settings are already kinda waterish. The depth and the shallow colors are already set. The only thing that's weird at the moment is the resolution is not correct. It will use, if available, the standard textures that are provided with the asset. You can find them under AS Water, the root folder, textures and then normal. I will change out the wave normal large with the foam 2 normal map. This will give a different kind of wave, as you can see. And since we use a rather large plane, we also have to adjust the tiling a little bit. So let's try 100 by 100. Depending on the plane, you have to scale the tiling in, on the axis non-uniformly in order to get a decent wave. This looks pretty decent. Let's do the same thing for the smaller wave map. So the gist of these two maps are that let's just give them the full strength at the moment. The shader will use two types of normal maps. Rather, it will use two wave maps. Wave maps are normal maps that the shader will use to create its waves. The most important part is that it will blend between the large wave and the small wave. The large waves will control the general look of your water. The small waves are the micro surface distortions. So you can use the same normal map for it twice, but I like to use two different ones to get a little bit more variety. So what is the strength value below it? It controls how dominant the wave map of that value is. So if I lower the strength value, the small wave map will become more dominant. And if I increase the large wave strength, the waves will become more smoother since it's dominating over the lower wave map. What I most of the time like to do is work with a 2:1 ratio. The large wave map will always be twice as strong as the lower wave map. So if we go with a strength of 20 for the large wave map and a strength of 10 for the lower wave map, you get a nice small watery surface. Now we will go to the most important map, which is the flow map. You can find the example that is already generated for this scene in the texture flow maps example folder, which is basically template. But you can also find it in the example folder itself of this scene. Go to flow maps and drag this one in this slot. As you can see, immediately the water will look differently. But as you can see, the normals now will be changing their flow direction based on the information provided by the flow map. So we can enable debug flow map for this in the shader. And it will debug for us how the shader is mapping the texture to its surface. So let's hide this plane. For now, let's disable this plane because we've shown how to set up your own material. And let's continue with the plane that's already provided, since that's already set up. Now we will go over every single value in the shader. So if you go to the material itself, you will see the shader with all its settings. Now this can look quite intimidating, but I can show you it is not. It is laid out in a pretty logical way. So the first thing you will see is the reflection source. Now this one is completely optional, as if you're not using this one, and if you go to the bottom of the shader and you have forward reflections on, you will use the default Unity skybox and reflection pros. However, should you have a custom planar reflection or anything, you can feed that in here. At the moment it says cube map because that's the last thing I have used in it, but it will adapt to either a 2D texture or a cube map texture. The next setting is chromatic aberration. It's self-explanatory. Basically splits the light refraction within the surface. If you put this on 0, the chromatic aberration is off. There is a little performance overhead if you enable this, but it's just very small. The way this shader works is by using a grab pass. If you leave this on 0, only one grab pass will occur. If you either go to the negative, minus, or the positive, 3 grab passes will happen. 1 from the red channel, 1 from the green channel, and 1 from the blue channel. Let's see if I can find something with a little bit more. Here we go. I do not know how well it will go once it's encoded to YouTube, but basically if I have it on 0, you have the color below the surface. If I shift it to the positive side a bit, you will see that on the left side we have a blue color shift, and on the right side you have a yellow color shift. I like chromatic aberration in water. It's a behavior that you see a lot in it, but I do like to use it very subtly, so only just a few values. It's very subtle, but it will give a nicer feel to the visual of the water itself. Okay, so next we have the transmission value. I can show this the best by placing a light up at the water. So the transmission value is basically how much light gets penetrated and transmitted through the surface itself. Normally, when there is a light source and it's above the surface, light will enter the surface and will bounce back, and it will light the area under the water. The water itself also catches a little bit of light, so the upper area will also light up. What does transmission do? It will allow the light to penetrate the water's surface. So if I amp that up, as you can see, depending on the angle, light will be able to break through the surface. The flatter we go, the more water is in between us, and the less light will be able to reach us. So if I move this light above the water and under the water. Now, the transmission itself is also handy if you have very thin water surfaces or very small water objects. Say you have a ball of water. It will allow a light to pass behind the object and still be translucent. The transmission is basically a very fast approximation of translucency. Even with large surfaces, I like to have it on just a little bit. Again, if the value is 0, no translucency or transmission pass will be done. Let's remove this light real quick. The next important thing for your visuals is the index of refraction. Now, I try to get this as close to the real life values as possible. So if you look up the transmission of the index of refraction of water, the index of refraction of that will be 1.33. So if I place this at 0, you will see that the reflection and the surface itself is still influenced by the normal maps, but the reflection below it is completely static. It's just the same as the object itself. By adjusting the index of refraction, we will allow the pixels below to be influenced by the normals of the surface. So with this, you have pretty accurate water refraction. If you have an oil or another material, you can simply adjust the refraction value. We'll get something like this, for instance. But I like the water values more, especially when you're creating water. So then we have the default PBR settings of Unity. We have a metallic value. So we have a liquid metal over here. Keep in mind that amping up the metallic to its max value might cause some shadow issues below the surface. But for water, we just have it completely off. Smoothness, that's the default reflection intensity. Keep in mind, if you have a custom reflection source, that source will not blur depending on the smoothness value. It will only adjust the visibility of that reflection. The default Unity reflection will get smoothed and blurred. I like to have it not completely max, just so that we have that little bit of Fresnel in the background. Then the next part is the color settings. So the shallow color is basically the color that we can see. So that's where light is able to penetrate the surface and reflect back to us. And the deep color, most of the time you want to have this on black, because the deep color determines the color where light is no longer able to reach back to the camera or our eyes. So in the ocean, this happens when light will become pitch black because light is no longer able to be penetrate those amount of depths. It will get completely absorbed by the water. So if we slide this around, you can see this happening. So the water depth slider will control how dense your water is. So if you have very dense water, the light will already be 100% absorbed very close to the surface. For the water that we're using, as you can see, it's not that deep, it's about, I think, half 1 unit. So I'm gonna make sure that the bottom is slightly visible. The color depth controls to what extent the shallow color has influence on the surface. If I make my water a little bit denser, we can see this much better. So this slider basically controls to what point light will lose its own color value. So we can see here that we're at half the depth now, and that the color will only completely go black at the edge where light no longer is able to penetrate. So the lower this value, the smoother that transition will be. If the value is -1, of course, it's completely against the surface, but I like to have it on -0.9, so it gives a great gradient. So at -0.88 you have enough light penetrating the surface, and it then gradually will die off. So I will lower the density of the water so that light penetrates a little bit further. Keep in mind that the density of the water controls how the caustics behave. We'll talk about the caustics in a minute. Next we have the watercolor blend. This basically controls how much the shallow color influences the pixel that is grabbed. If this is off, there's no use in adjusting the watercolor. It will simply only rely on the water depth and the color depth. If watercolor blend is completely active, water depth and the color depth will use the shallow color to influence the final color of the pixels. For the water rim depth, the water rim fall off and the rim intensity, we have two textures. We have the rim texture itself. In this case I have a foam texture. And the rim normal, which is derived from the grayscale of the foam texture. What this basically does is uses the depth pass that is used for the water depth calculation to also draw an edge where surfaces meet. In this case I have a little bit of foam floating on top of it, and the normal map itself of the foam is stretched around it. If you give it the same resolution as the foam, the normals will match completely. So if you have light over here, you can see that the normals themselves influence that. So now we have light scattering of the foam and everything. The foam is like gently floating on top. Most of the time I have the foam texture off because I like to play a little bit with the normal texture more. So if you go to the rim normal and just put it on 10 by 10, it will get stretched along that surface. So what enables us to do with this is we can play with the fall off of this for how smooth it will transition from full normal to nothing. And we can control the rim depth to where that normal influence should go. So as you can see now, my objects have real-time rims around them. Even this stick. And if you turn the slider all the way to the right, the rim will no longer be visible. So now we've talked about our rim settings, so we can go a little bit further down. We have our normal large, our wave normal small, and our flow map. Now the flow map is a little bit more complex, hence why it's a separate video. It uses the red-green value of the texture to store its vector field, and the vector field will influence the UV distortions of the rim texture, of the wave normals, of everything. The complete shader uses the flow map as a base to control everything it has. So in this case I already talked about the intensity values and the functionality of the wave maps. So I'm gonna skip this one. So the flow map stores its vector field in a red-green value. The second value of the third channel is the blue channel, which will control the visibility of the waves. It's basically just a high map that gets multiplied over it. But it gives the user the ability to create quiet areas within the water. So as you can see, the water is breaking through the small surface. The waves get less and less intense because there's more distortion going on. And in this corner that's completely out of the reach of the main flow, the water is completely still. We also have a quiet area over here. The water breaks through this area and it gets distorted more and more until it's completely flat. One important thing to keep in mind is that this shader will always render in forward rendering. Even if you are explicitly using deferred rendering, this shader will render itself in the forward render mode. This is because the only way at the moment to get a decent pixel grab that has all the information is through the forward render pass. Now, back to the flow map. I explained in short which channels are used by the flow map. So, we have two values that can influence the flow map a little bit, which is the flow power, which will determine how much influence the flow map has on the normal. So the higher this value, the more extreme the flow bending will be. Of course, if you go too high, everything will become distorted. Most of the time I like to keep this on 1 or 2, depending on how strong your flow map is. So we have two values that controls the flow map. We have the flow power, which we saw a moment ago, and the flow offset speed basically controls how fast the water is flowing. If you leave both values at 1, you will have the actual flow that is stored in the flow map itself. With this texture, since the flow is a little bit slow, the water seems way too thick, I will set it on 2 and we have a more natural behavior. Lastly, we have the caustic map. So you can do this in two ways. You can either store a texture in it or you can store an animation sheet in it. The intensity simply controls how visible they are, and the contrast controls how intense they are. So if I amp this up completely and I open up the intensity, it will overwhelm everything. I like to balance it out so that it's quite visible in the shallow area and that it will be more difficult to notice in the deeper area. So one important thing to note is that the caustics themselves, since they are just a texture, they have to be mapped to fit around the surfaces. Again, the same as with the shallow and the deep area, this is done through the depth map. So if the water depth and the color depth do not have high enough values, the caustics themselves will not get wrapped around the surface. And we can see that if we lower the water depth completely, the texture will be completely flattened out over the surface. So it's always good to have at least a little bit of this value, even if you have completely shallow water. Even though it's an animated tile sheet, you can still tile texture itself, as long as your texture is loopable. If your texture is not loopable, you will obviously get to see seams everywhere. So if I put this on 10 by 10, the caustics will be incredibly large. 1000 by 1000, they will become smaller. Then the texture sheet itself is controlled by a vector 4, and this vector 4 stores quite a lot of information. The first two values, the x and y value, control the animation sheet if you have one. So you simply have to put in the columns on the left and the amount of rows on the right. Then the shader itself will cycle through the texture sheet and play the animation as we see it over here. Then the Z value is a starting frame, so if you have a very distinguished look per frame, you can cycle through the start frames with this value. Even if you have float values, it will simply round it down or up to use that frame, since frames are integer values. You can start from frame 10. Again, since it's a loopable animation, we won't notice any difference, so I'm just gonna leave it at start frame 0. The last value, the W value, is pretty important because this is the frame rate. It's the speed of the animation. If I place this on 1, you will see it will update the frames only periodically, once per second. If I place this on 10, we have a little bit of movement, it's a bit jittery. But I created my my caustics with Substance Designer, so I was able to create a loopable sheet that's stylable and that loops its animation at 60 frames per second. Lastly, we have this default forward render settings, so if I turn to the sun a little bit, I can disable the specular highlight, because it's forward render pass, or I can completely disable the reflections. Why would you want to disable the reflections? Again, if you have a custom reflection or you have a custom planar reflection calculation. Now you can also use both. You can leave this one enabled and then still use your custom reflection short. Keep in mind that it will not blend the same as reflection probes. Probes will blend into each other. This one will completely write over the available reflection source. So that's something to keep in mind. So we're getting to the end of the video. We've went over setting up your material, your shader. We went over each and every individual setting. So normally, if everything's alright, you should be able to get going by yourself. Have a nice day, and I will see you in the next video where we will go into detail on how to generate your own flow map to get started with. Bye!